Welcome back to the AI Waves channel, your go-to source for all things AI. If you're fascinated by the boundless possibilities of artificial intelligence, you're in the right place. Don't forget to hit that like button, subscribe, and ring the bell to not miss out on our weekly deep dives into the AI revolution. Artificial intelligence has gone from science fiction to an integral part of our daily lives. It's the silent, intelligent coworker that never sleeps, tirelessly crunching numbers, making predictions, and even helping us find that perfect movie for a Friday night. From the way we shop to how we communicate, diagnose diseases, or navigate the roads, AI is reshaping the world in ways we could have only dreamed of just a few decades ago. But let's pause for a moment and consider the complex machinery that powers this revolution. Have you ever stopped to wonder how these digital minds learn to think for themselves? Much like how a newborn learns to recognize faces, or how a puppy learns to respond to commands, AI also learns from experience. This learning process, intriguingly similar yet fundamentally different from our own, is what we call machine learning. Machine learning is the bedrock of AI, the foundation upon which these intelligent systems are built. It's the magic that allows your virtual assistant to understand your voice commands, or your music app, to suggest songs that match your taste. It's what lets a self-driving car navigate through a bustling city, or a chess-playing AI to anticipate your next move. At the heart of this learning process are algorithms, the unsung heroes of the AI revolution. Algorithms are sets of rules and instructions that guide AI systems to solve complex problems. They're the architects that shape the way an AI system perceives and interacts with the world. Think of an algorithm as a recipe. A recipe provides step-by-step instructions to turn raw ingredients into a delicious dish. Similarly, an algorithm takes raw data, processes it, and churns out valuable insights. But unlike a recipe, an AI algorithm doesn't just follow instructions, it learns from the data, refining its process over time to improve its performance. So, if you've ever wondered how your smartphone knows when to suggest an umbrella, or how a streaming service can predict the next big hit, remember this. At the heart of AI's ability to think are algorithms, sets of rules and instructions for solving problems. But how does machine learning actually work? Let's break it down. Imagine you're teaching a child to recognize animals. You show them a picture book with a variety of creatures and start pointing out each animal by name. This is a dog, you say. This is a cat, and so forth. Over time, with enough examples, the child begins to recognize animals on their own. They've learned from the data you've given them, the images and the names of the animals. The process of machine learning is not much different. It involves feeding an algorithm, which is essentially a set of rules to solve a problem, with a lot of data. This data can come in many forms: images, sounds, text, numbers, and so on, and it's labeled to help the machine understand what it's looking at. For example, in our animal recognition scenario, the images of animals are the data, and the names of the animals are the labels. The algorithm processes this data, learning from the patterns it finds. This is often a trial and error process. The algorithm makes a guess about what's in the data, compares its guess to the label, and adjusts its rules based on whether it guessed right or wrong. For instance, let's say we're teaching our machine to recognize dogs. We feed it a bunch of images, some of dogs and some of other animals, each labeled appropriately. At first, the machine might guess wildly, unable to differentiate a dog from a cat or a bird. But each time it gets it wrong, it tweaks its rules a little. Maybe it starts paying more attention to the shape of the ears, or the texture of the fur. Over time, with enough examples, the machine gets better at recognizing dogs. It has learned from the data we've given it. But here's where things get really interesting. Once the machine has learned from the labeled data, we can start giving it unlabeled data images it hasn't seen before, without any names attached. And if our training has been effective, the machine will be able to identify dogs in these new images. It has not only learned to recognize dogs, it has learned to generalize from its training to new, unseen situations. So, in essence, machine learning is a process of learning from examples. It's about finding patterns in data, and using those patterns to make predictions or decisions. It's a powerful tool that drives everything from voice recognition to medical diagnoses, from stock market predictions to autonomous vehicles. But remember, machine learning isn't magic. It's a tool, a process. And like any process, it requires the right ingredients. In this case, those ingredients are data, algorithms, and I mean a lot of examples. To help us understand the significance of data in AI, we have an AI expert with us today. Data, the raw material of artificial intelligence, is the cornerstone upon which AI models are built and trained. Think of data as the fuel that powers AI. It's the information that AI uses to learn, adapt, and improve. Without data, AI would be like a car without gas. It simply wouldn't go anywhere. The more data we feed into an AI model, the better it becomes at recognizing patterns and making predictions. For instance, if you want an AI to recognize images of cats, you'd need to feed it thousands, if not millions, of cat pictures. The AI then uses the data to learn what a cat looks like and can then identify a cat when it sees one. This is the essence of machine learning. But it's not just about quantity. The quality of data is equally important. To ensure that AI models function effectively, they need accurate, unbiased data. This is where we encounter some of the ethical considerations in AI. If the data is biased, the AI model will also be biased. For example, if an AI designed to screen job applicants is trained on data from a company that has historically hired more men than women, the AI might unwittingly perpetuate that bias. In real-world applications, data is used in myriad ways. AI models are used to predict stock market trends, diagnose diseases, and even predict climate change patterns. Each of these applications relies on large data sets to train the AI models, enabling them to make accurate predictions. As we move forward in the AI revolution, the importance of data cannot be overstated. It's the lifeblood of AI, enabling machines to learn, think, and improve. But with great power comes great responsibility. As we continue to develop and deploy AI, we must ensure that we're using data ethically and responsibly. Data plays a crucial role in training AI models, enabling them to learn and improve. Without data, AI would be like a ship without a compass, adrift and aimless. But with the right data, AI can chart a course to a future full of incredible possibilities. Now, let's talk neural networks. These are inspired by the human brain and are key to giving AI a semblance of thought. Neural networks are the backbone of AI, the secret sauce that allows machines to learn, adapt, and ultimately, to think. Imagine a neural network as a sophisticated web of interconnected nodes or neurons, just like the billions of neurons present in our own brains. Each of these neurons receives input, processes it, and passes on the output to other neurons. This is much like how our brain cells transmit signals to each other. The magic, however, lies in the connections between these neurons, also known as weights. These weights determine how much influence one neuron has over another. They are tweaked and adjusted during the learning process, allowing the network to improve its performance over time. This is where the learning in machine learning comes into play. In a neural network, the neurons are organized into layers. The input layer receives raw data, such as pixels in an image or words in a sentence. The hidden layers, which can number from one to many, process this data, extracting features and patterns. The output layer then makes a decision or prediction based on this processed information. This layered structure allows neural networks to handle complex tasks, from recognizing faces in photos to translating languages in real time. They can identify patterns and connections that are too complex or subtle for human brains to catch. This is what gives AI its intelligence. But it's not all smooth sailing. Training a neural network can be a resource-intensive process, requiring vast amounts of data and computational power. And even then, the end result can be something of a black box, with decisions made in ways that are hard for humans to understand. Despite these challenges, neural networks are revolutionizing our world, powering advancements in fields ranging from healthcare to entertainment. They are the brains behind the AI revolution, the engine that drives the magic of machine learning. Neural networks consist of layers of nodes or neurons that process information based on the connections and strengths between them. Just like us, AI learns from experience, but instead of learning from personal experiences like we do, artificial intelligence learns from data. Lots and lots of data. This is a process we call training. In the training phase, AI systems are fed vast amounts of information, kind of like how a student crams for an exam, but on a much larger scale. This data can be anything from images and sounds to text and numerical figures. The AI system then uses this data to make predictions or decisions. Think of it as a toddler learning to differentiate between different animals. Initially, they might not know the difference between a dog and a cat. But as they are exposed to more and more images and real-life instances of dogs and cats, they begin to understand the differences between the two. Similarly, AI systems learn to distinguish between different data points and categories through repeated exposure. But here's the catch. The quality of learning heavily depends on the quality and diversity of the data provided. Just like us, if AI is taught with biased or limited information, the results can be skewed and inaccurate. Therefore, the data used for training needs to be comprehensive, diverse, and as unbiased as possible. So, you see, AI learning is a combination of advanced algorithms, good quality data, and lots of practice. And just like us, the more it experiences, the more it learns, and the better it performs. The more data, the better the AI can perform. Let's look at some real-world applications of AI learning from data. In healthcare, AI is used to predict diseases even before symptoms appear. Researchers have developed algorithms that can analyze medical images and detect early signs of conditions like cancer, sometimes even outperforming human experts. In the field of finance, AI is revolutionizing the way we manage and invest money. Algorithms are used to analyze market trends, predict stock movements, and even automate trading, making investment decisions faster and more accurate than ever before. And let's not forget about environmental science, where AI is playing a crucial role in climate change research. Machine learning models are being used to analyze vast amounts of data on weather patterns, helping scientists predict the impacts of climate change with increasing accuracy. These case studies show the potential of AI when it's given the right data and training. It's not just about creating smarter machines, but also about harnessing their power to solve some of the world's biggest challenges. As we've seen, AI's ability to think stems from complex processes of learning from data. It's akin to a child learning to recognize animals, but on a much grander scale. Algorithms, the backbone of AI, decode intricate patterns, and machine learning enables these systems to learn and improve over time. Neural networks, inspired by our own brains, process and interpret this data, giving AI a semblance of thought. We've also seen the incredible potential of AI, from enhancing healthcare to revolutionizing finance and tackling environmental challenges. Each success story is a testament to the transformative power of this technology. Yet, like any powerful tool, AI is not without its challenges. As we continue to develop and implement AI systems, ethical considerations and the importance of responsible AI come to the forefront. But one thing is certain, the future of AI is both exciting and full of endless possibilities. What do you think the future holds for AI? Let us know in the comments below. If you're intrigued by how AI is transforming our world, make sure to like, share, and subscribe for more insights. Your support enables us to keep bringing you the fascinating world of artificial intelligence, breaking it down into digestible bits. We're on an exciting journey and we want you to be part of it. So stay tuned for more deep dives into the AI revolution. Join us next time on AI Waves channel, where we'll explore the ethical implications of AI. If you're intrigued by how AI is transforming our world, make sure to like, share, and subscribe for more insights. Join us next time on AI Waves channel, where we'll explore the ethical implications of AI. Until then, keep questioning, keep learning, and ride the waves of AI with us. Until then, keep questioning, keep learning, and ride the waves of AI with us.